All right, and we are now ready for doing some example. So let me now introduce our first example. So example 1, and let's see how we can apply the chain rule into various situations right here. Okay, so it's just the entire example 1 is just that standard find the derivative of a given function. So find f prime, or in some when it's in equation notation, then we find dy dx. So part A of the example, we are looking at how about our given function here as being a 4 in parentheses x to the 4th minus 4x raised to the 10th power. Okay, so raised to the 10th power. All right, so for any viewer here, allow me to assume that you're very beginning into this. So I am going to take really careful step in terms of tracking down the inside, as in the previous part of the lecture over here, as in the earlier part of the lecture. I am going to track down the inside and the outside for that. So in this particular problem, I am going to choose, and hear my term here, I am going to choose this part right here to be the inside right here. And naturally speaking, what caught my eye here is that this expression x to the 4th minus 4x that I'm underlining right here is being inside of a parentheses and then being raised to a power. So it rings a good bell about this could be a well qualified candidate to be the inside function. And so that means I can substitute a variable u to equal x to the 4th minus 4x. Okay, and yes, this is what we can call this now the inside function. Or alternatively, anyone can refer to this as a function g of x being the x to the 4th. I'm trying to make it very similar to how I was lecturing earlier regarding the recognizing the inside and the outside. So there are two different styles here. Just we take one expression and letting it be substituted by we're going to replace that entire expression by an external variable. Whereas here we're going to define our function as, we are defining the entire expression here as a function g of x. Okay, so similar idea, but slightly different way of notating the problem right here. But so either we're calling that g of x or the letter u right here, lowercase u, or the uppercase u should all be okay here. But now once we recognize the inside and substitute away, then see quickly let's tackle down with this expression right here and a little bit on scratch work. If we let u equals x to the 4th minus 4x, right, then back into the expression itself, then it's going to be, you see, the x to the 4th minus 4x and being raised to the 10 with a 4 in front. You see, only this part that I underlined being substituted. So that part right there is becoming a u, but everything else remains outside of that u substitution. Everything else is remaining the same. So 4u times 4 times u to the 10th power. So this means we have a well recognized that part right here, 4 times u to the 10th being our outside function. Okay, and so back to my formal work. So now I'm recognizing that 4 times u to the 10th power. Okay, and of course this is y equals, right, and then I recognize that as my outside function. So now once we start tracking down where the inside is and where the outside is, then right here in this notation, then you can see that, you see the reason I call it inside, because this expression is being hidden, being embedded inside of this u variable. So that's one way of understanding it. And or alternatively, if we are using the functional notation, then the outside function, we can call that a function f of x here, some function f of x. Okay, not the main function, but some function f of x here. So think about this entire expression. If we hide away, because that part is being substituted, being regarded as g of x. So if we hide away this expression right here, then what we have remained is some coefficient 4 times with a variable, some variable. So how about we can reuse that variable's name? So coefficient 4 times some variable but raised to the 10th. So this is, in functional notation, we can also regard to this as our outside function. Simply in the sense that our final function y right here is f, but taking g inside of that. Okay, so much explanation. Two different ways to explain the situation. Okay, and I'm, trying to proceed a problem in two different styles right here. So now let me navigate to the other board right here, and we are going to continue the problem. And so once we have successfully identified the inside and the outside, then we are ready for our final derivative. And allow me again to split the board into two separate areas. So if we are staying with the traditional dy dx symbol, or just stay with the style on the left hand side, if we're staying with this style of notating the symbol by using just short variables like this, then remember the chain rule says we take the derivative of the outside first, so which is namely dy du, okay, and multiply with the derivative of the inside function, and the inside function is du dx. So dy du quickly is that is the derivative of the 4 times u to the 10th power. Take the derivative. So that means we're looking at 4 times okay, and I can just combine all together. So here is actually 40 times u to the 9th power. But this is only the derivative of the outside function. But then when we're writing it this way, make sure your final derivative of the outside function has to be having that actual. So remind yourself that u is substituting for x to the 4th minus 4x right here. So that means here, instead of writing u, I am going to write x to the 4th minus 4x to be inside of that u variable. So that's the outside and the inside is here, but we keep for now taking only the derivative of the outside, and we're going to leave the inside exactly the same, okay, and to the 9th power. But then, and then my du dx, okay, we let u equals x to the 4th minus 4x. So du dx here is going to be 4x cubed minus 4, okay. And so now our final derivative, as proven by the formula right here, as being indicated in the formula, then final dy dx is simply going to be, okay, so 40 times x to the 4th minus 4x, okay, in parentheses to the 9th. So that's the derivative of the outside, but now we need to multiply with the derivative of the inside, which is now x to the 4x cubed minus 4. But that is how we found our derivative of the function. And then in the other style, quickly in the other style, once again the inside was recognized as g of x here, and the outside is the 4x to the 10th function. And so in that way, finding dy dx, the formula said find the derivative of the outside function but keeping g inside. So in some case, using this formula is a little more direct, but it takes a little more time to understand. But it does require anyone who proceeds with this formula to be a little more fluent in terms of understanding the concept of composition of two functions. Okay, but if you can understand that concept just fine, then going with this formula is a little more direct actually. Okay, so that's now multiplied with g prime of x. Okay, and so f prime is as we have seen that back in the function. f prime, the outside function. So we bring the power down in front and multiply with 4 and getting a 40, and then the input variable being raised to the ninth power. So, but in here, the formula says f prime at g. So now I'm going to say f prime at g, the derivative of the outer function. So that means we're adding 40, but then at g, that means I'm leaving the entire x to the 4th minus 4x here inside of g, inside of f prime, and now raised to the 9th power. So this is f prime at g right here, f prime at g. Okay, and then we need to multiply with the derivative of g prime. So recall that g prime we've had earlier. It's right here. Okay, so now having g equals x to the 4th minus 4x, then g prime is simply just a 4x cubed minus 4. Okay, and once again, the two answers agree. So now, as I show this first problem in our example in two different styles. Now, being the teacher here, anyone taking class with me, I don't require my student to show the steps in both styles. So you just choose one, whichever that's more comfortable for you. You go with that style, and I should be flexible enough to welcome any of your work. But you definitely only want to stay in one style of your work right here. That saves yourself some effort. Otherwise, it's almost like you're doubling your amount of work and spending double the amount of your effort. Yeah. Okay, and so that's how we've done with the first problem. Okay, and that was part A in our example. All right, and now I'm getting back to my other board, and let's look at part B of our example. So here, I am going to, let's see how we can apply the chain rule into a different situation of our problem. So how about y equals 8 times the square root of, let's say, x cubed plus 5x. Okay. So x cubed plus 5x. So now, once again, first responsibility is to recognize the inside function. And so in the style that we substitute value, then I am going to, well, in my experience, at this point in my experience, for now, I'm sharing my experience, and then as I show enough examples, you know, anyone watching the video is going to start getting a hang of it. That's how can you, which expression can you choose to make a good substitution? I mean, to make a good inside function. Okay, so for this problem, I would choose this one. Okay, so now I'm gonna let u in the style of that we directly substitute the inside for an external variable. Then this is u equals, I'm letting u equal x cubed plus 5x. Okay, and yes, so now we refer to this as the inside function. So at this time right here, after doing a few problems, including our first our example 1 part A earlier, then it looks like it's always starting out, we always start out by finding the inside function first. Okay, all right, and so, well, just a little bit about my experience, how did I decide to choose this? Now, it's simply because I see that this entire expression is being trapped inside of a square root expression. So why not just take the whole thing? See what I'm saying? So, and then of course I will, at some point after this example 1, I am going to give another detailed look in terms of how you can successfully choose a good inside function. Okay? So when we choose an inside function, then of course, for the outside function, it's going to look as following. Now back to the now and allow me to start speeding up the process a little bit. So now the entire expression here, the entire problem here, but once we substitute this expression inside the square root away, by the u variable, then we're going to have remains that what we have remains here is y equals 8 times square root of u. Okay, and now what I see here is that this final expression has no x variable left. So x variable was the variable that was initially involved in the problem, but once we substitute it away in this style, once we substitute it away, then for the outside function, and it doesn't have any additional x variable left over, so it's completely in terms of u once you substitute that away. Okay, or in the other style of naming your inside and outside, so inside here we can just, according to what I chose, x cubed plus 5x, but now I'm going to refer to that as some g of x function, and this is going to be the function being put inside, being composed inside of another function. And then for outside function, I can see that you see it's a 8 times square root of something, instead of seeing as a u here, square root of something, of any variable. And so I can call that f of x here, regarded as the outside function, 8 times square root of x. Okay, and recall for yourself, in either way, a square root is eventually a power 1/2. Okay, so think of that as 8 times x to the power 1/2. I wrote 1/8 here. Power 1/2, and the same with the u variable. We can rewrite this as y equals 8 times u to the power 1/2. Okay, and so now we are ready for finding the actual derivative. So again, I am going to develop the problem in two different styles of notation, but viewers who are my students are only expected to stay with one style, whichever that's more comfortable for you. So now dy dx, so you can see that we need dy du and du dx. So I'm going to separately find dy du and dy du here. Equals 2. So let's look back at our u expression here. So if y being expressed as a function of u, then it's y equals 8 u to the 1/2 power. So that means dy du simply turns out to be, so 8 times the 1/2 power multiplied down, and u is now raised to the power negative 1/2 because of 1/2 minus 1. Okay, so 8 times the 1/2 u to the negative 1/2, and the 8 cancels with that 1/2 here, leaving behind a final coefficient being 4 times u to the negative 1/2. But going with this form is a little bit unclear in a sense of the indication, but we don't stop right here, but we need to actually remind yourself that u equals to x cubed plus 5x. So make sure your final dy du is indeed being written in terms of the x variable. So it's 4 times x to the x cubed plus 5x, and being raised to the negative 1/2 power. So that's one separate part for du dy. This is the derivative, or saying it out verbally, this is the derivative of the outside function. So inside function, du dx, are simply because we define u separately as an external variable, being a function x cubed plus 5x. So I can find the derivative du dx, and so that now would be simple basic simple power rule, and those basic rules for derivative simply applied here. So we're looking at 3x squared plus 5 here for our derivative there. So now we are ready to make our final derivative. Okay, so dy dx equals to this derivative of the outside. Let's put it in. 4 times x cubed plus 5x being raised to the negative 1/2 power. Okay, that takes care of more than half of the problem already. And now we're going to multiply with the derivative of the inside function, which is the 3x squared plus 5. But now, all of a sudden, we realized we are done. And usually when it comes to the chain rule here, the simplifying or not, I leave that for viewers to watch out for your own instructor's indication. So some instructors indicate that students need to reduce their expression, their final expression of the derivative here, and some other instructors do not require simplifying, and as a matter of fact, some instructors even ask students to leave the answers without a reduction, without simplification. So in my examples here, I am going to leave the final answer here without simplification. So, but we found the answer to that derivative. Let's look into the other style. Same problem here, but what if we went with the other style, which is a little more direct? Here, our inside function is being regarded as the function x cubed plus 5x as a g of x. And then I see my outside function here can be regarded as that 8 times square root of x. And then eventually being turned into an 8 times x to the 1/2 power. Okay? And so in that way, derivative, the formula says we need f prime. So here allow me to rewrite that formula. Chain rule says, and if we go with this notation, then f prime of g, okay, I gotta spell it out really out loud right there. F prime of g, the derivative of the outside function at the inside function right there. The derivative of the outside but evaluated at the expression being the inside. And I'm gonna multiply with g prime of x, the derivative of the inside function at x, at the input x. And so with that clear indication, then see, derivative of the outside function is once again 8 times 1/2 times, and see this empty pair of parentheses here, I am going to put in my inside function, my g of x function. So that is where I put the x cubed plus 5x there. All right, and now that here, this is raised to the negative 1/2 power. So 8 times 1/2, whatever that is here, to the negative 1/2, this is the f prime of g. Okay, but now I am going to multiply with g prime. So g prime here is simply that 3x squared plus 5. And notice we can again cancel 8 with 1/2, so our very final expression here without simplification, then being 4 times x cubed plus 5x being raised to the negative 1/2 power times in product with 3x squared plus 5. And again, we are done simply because I see that this answer we just arrived now has exactly agreed with the other answer we have obtained earlier. All right, so let me now introduce the next problem in our example. All right, so part C of the example. Part C, question C here. Let's say, how about y equals a constant 5 over, and how about x to the 4th power minus 5x cubed plus 4. Okay, so we have what we have here looks like a rational expression. Yes, it is a rational expression. So, but since I purposely, since we're in the discussion about how to apply chain rule, so of course, if any viewer can find a way to get this derivative by going through the quotient rule, that's fine. But the point of this lecture is about to see how we can apply the chain rule into a problem like this. Okay, and so in that way, I am going to purposely apply the chain rule. So here, I am going to underline the entire, or maybe put in a red box, the entire denominator of our quotient right there. And I call that my inside function. Okay, And so that means in that way, I'm going to let a variable u to equals x to the fourth minus 5x cubed plus 4. And I call that in that. So this is my entire denominator of the beginning expression. But that there is being regarded as the inside function, okay, or the inside expression, ready to be substituted away. And so if we substituted u to equals all that entire expression there in the denominator is being substituted by u, then that means consequently the function itself, the entire function, the entire y variable is now equal 5 over, but instead of the whole ugly looking thing here, it's now become just simply a u. Y equals 5 over u. And no other extra x variables remain here. So that means we now have completely substituted away the x variable expression. And so now this can be regarded as our outside function or outside expression. Okay, and note further that this outside expression can be regarded as rewritten as, see how the u is in the denominator, power 1. So we can rewrite this as a 5 times u to the negative 1 power. Okay, to the negative 1 power. All right, same way for the other function right here. For the other style inside function. Okay, so for inside, we have already chosen this, and at some point I will discuss how I can tell if which expression can be a good candidate for being the inside function. So here I can regard to all that x to the fourth minus 5x cubed plus 4 to be the inside function g of x. Okay. G of x. And so that means if we think about, if we hide away completely this, then it's just some variable being in the denominator here. And that variable now is, and that entire expression here is going to look as following, just 5 over some variable. Let's name it x again. Okay, but this is now f of x. So think about, if we put the entire g of x inside of that x variable in our f of x here, then we're going to produce this overall function. So this f of x here is our outside. Right? It's our outside function. And I'm a little bit too squeezed in right here. So this is outside function. All right, so in that way, and of course this outside function can be also further understood as 5 times x to the negative 1 power again. So very similar to the other arguments. So now we are ready to navigate to the other board and get the problem done. Okay. All right, so after clearing out my board in 2 different styles again, then the style that explicitly shows the u substitution, then here shows the external variable substitution. Then here just recall that we substituted u to equal x to the fourth minus 5x cubed plus 4. And yes, this is in the other style, this is also regarded as the g of x function. But now, so dy du is going to be, now recall for yourself, y as a function of u. After we recognized our inside function and substituted all that for a variable u right here, then we recognized our outside function being y equals 5 times u to the negative 1. All right, so let's find dy du. So 5 times negative 1, because the power comes down, multiply with u, but now to the power negative 2 power. or 5 or negative 5 times u to the negative 2 power. Okay, and in the earlier part I immediately substitute the u in, but that's not even strictly required, so we can leave that here. We can leave that here, and then I'm going to move on to the next step, du over dx. I'm talking about in case anyone don't remember to substitute the beginning u substitution into this current dy du. That's okay. It's not as strictly required. And then we're going to put it all together at the end. It's also going to be working. So du dx here, this time u is defined as x to the 4th minus 5x cubed plus 4. So du dx here is going to give me 4x cubed minus 15x squared, and the constant term is gone away. And so now our final derivative, the final derivative dy dx, requires us to put in dy du times du dx. So remind yourself about that. And so now putting the pieces together, dy du is this. So negative 5u to the negative 2 power. It's still okay that I have not substitute back the original substitution for what u was. It's okay to leave it like that. And then multiply with, so now du dx here is the 4x cubed minus 15x squared. But now keep in mind, at this point, the reason why we have to strictly bring the original substitution of u back in for where it's supposed to be, because our final expression here, our final derivative is required to be in terms of x. Okay, and so now minus 5 times, but just simply bring back what u was. The u was defined, was substituting for x to the 4th minus 5 minus 5x cubed plus 4, and to the negative 2 power, so in parentheses to the negative 2 power, and multiply with all that 4x cubed minus 15x squared. Okay, so now we've found another derivative. Okay, and so just like that, again, allow me throughout the entire example 1 right here, work on the other style of finding this derivative. So if we recognize that g of x is the inside function, so recall for yourself, g of x was x to the 4th minus 5x cubed plus 4. And so now the derivative right from the beginning, the dy dx, according to chain rule. The chain rule says, in this form, the chain rule says we need f prime of g. Okay, f prime evaluated at g of x, multiply with g prime of x. Okay, and so f of x is the outside function is the 5 times x to the negative 1 power. Okay, and of course g of x, the inside function, is x to the 4th minus 5x cubed plus 4. All right, and so this is going to be, so the derivative, so f prime. So f prime is going to be 5 times the negative 1, because the power comes down, and multiply. But f prime, so this indication here is strictly required, but it's kind of all in one step. F prime at g. So in this parentheses, and of course, let me now leave that parentheses here empty. But the whole idea, the whole structure of f prime now is 5 times negative 1 times the input, but being raised to the power negative 2, because power is reduced, is being subtracted from 1. Okay, and so now, but all that x to the 4th minus 5x cubed plus 4 is being inside here. So this complete thing is f prime at g. And now I am going to multiply with g prime. So g prime here is the whole 4x cubed minus 15x. And I just realized now that I'm a little bit running out of space, so let me rewrite the whole thing here. 5 times negative 1 x to the fourth minus 5x cubed plus 4 to the negative 2 power, and now multiply with 4x cubed minus 15x squared. And this is, ladies and gentlemen, the derivative of the inside function, or in other words, this is g prime. Okay, and so completing the entire expression together, and it's negative 5 times x to the fourth minus 5x cubed plus 4 to the negative 2 power multiplied with 4x cubed minus 15x squared. And this final answer once again agrees with the final answer we have done in the other with the other notation. I wouldn't even say that this is the other solution. It's pretty much the same solution. It's just different style, slightly different style of using notation. Okay, but the reason I say this is one solution because in the end we are just exactly using the chain rule. So that's one solution. It's just we laying out the steps differently, slightly differently. That's all there is. Different style of laying down the steps. Okay. And once again, I'm going to erase the other board and let's get ready for another problem. All right, so now let's look at part D of our example. So now, how about y equals, I'm going to look at negative, I'm getting tired of 5, so how about negative 10 times, over, and here I have x squared plus 5. Okay, how about 5x squared plus x squared? Change my mind a little bit. Sorry about that, but I just want to be, as crazy as possible, so that you can get a hang of the kind of idea that we can apply that no matter how the problem changes different things. And so now I'm going to put a power, 4. Okay. So when it gets to this problem, or a problem like this, then I am going to, and once again allow me that throughout the entire example here, I am introducing my own experience. And then as you have seen enough by the end of example 1 where we are ready to move away from it, you're going to start getting a good hang of it. So I am going to underline this expression right here, not the whole, including the x, including the fourth power. I'm not doing it that extreme. I'm not substituting it that extreme. I'm only going to pick the 5x squared plus 1, okay, inside of this power right here to be my substitution if I'm going with the substitution route. But in general, I regard to that as my inside function. So here I'm going to call that a letter u. And please, you got to understand that u here is just a naming choice of an external variable. You feel free to use a z, a t, an s. Just don't use the x again because it's going to make a serious misleading misunderstanding. Okay, so you can use u, you can use t, you can use v, z, whatever, but it's just a naming choice of the variable. So it looks like I stick with u for quite some time, but it's okay. It's just some variables name other than x, and of course other than y. But now u equals 5x squared plus 1. Okay, so once I substitute it for that, I can just simply regard it to that as the inside. And now once I have decided my inside, then here comes my outside. The entire expression, looking back at the entire expression, then after substituting away the ugly looking thing inside of the fourth power in the denominator, then I have now y equals negative 10 over u. See how shorter it is now? Significantly shorter, but u to the fourth power. Okay, so I made the expression, the substitution gives some good advantage in terms of keeping things shorter and then more condensed. And then I can now regard to this as the outside expression. Okay, and And further, we can see that this can be understood as a negative 10 times u to the negative 4th power. Okay, so minus 10 as a coefficient, the negative 10 on top right here is a negative 10 coefficient times the variable u being raised to the 4th power, the negative 4 power. Okay, so that's my insight as being a choice of being a choice of decision. And once we chose that and substituted it away, the entire expression became whatever. And just make sure that there is no extra variable x that's being still left behind right here. That's all it needs. So as long as the x variable is being washed away, okay, then we're safe to consider this, to regard this as the outside expression. Okay, and so similarly, the inside function that we have chosen here can also be regarded as the g of x equals 5x squared plus 1. Okay, and the outside in that case, going this route is a little bit challenging at the step where we're recognizing the outside and the inside. But the outside is just, see, 10 over something to the 4th. I said it verbally, negative 10 over something to the 4th. So that something is just another input variable. So negative 10 over something to the 4th. So how about negative 10 over x to the 4th? Okay. And so same way, but now once we recognize that, and it looks just like the other form right here, and we can once again think of this as negative 10 times x to the minus 4 power. Okay, so inside and outside functions are all ready. So let's move to the other board and get our complete solution up. All right, and so now once again in two separate columns, same solution, but I'm delivering into different styles of notation. But so recall again that in this style, using a clear, explicit variable to substitute for the expression that I chose to be the inside, and u equals 5x squared plus 1. That's just a small little reminder. So that means now I am first going to find my dy du, and allow me to roll back to the other board because I don't want to rewrite too many steps from the previous steps right here. But see, this is my y as a function of u right here. So y equals a function of u. And so dy du is right out from this, or in other words, the derivative of the outside function. Okay, so clearly speaking, hopefully I spoke clearly enough that this is the derivative of the outside function. So dy du. So dy du now is going to be negative 10 times a negative 4. And don't worry, don't overpressure yourself. Anyone viewing this video, don't overpressure yourself about getting that substitution back in here at this point yet. It's okay. If you forgot, that's completely okay. Okay, this is negative 5 power. After the power initially, after the original power is being subtracted from 1. Okay, so dy du a little further becomes 40, positive 40 times u to the negative 5. Okay, so and like I said, in case you so forgot about substituting back that u expression into this, that's completely fine. We can do that all the way at the end in this style of presenting your work. Okay, so here the next step now is I'm going to need to find the derivative of the inside expression. So now it's a du dx. Okay, so du dx here is going to be simply 10x. See, power 2 multiplies down, giving me a 10. The power reduced by 1, 10x. The constant term is gone. Okay, and so now putting it all together. So recall again, the final dy dx, chain rule said, in this style of notation, chain rule said we take dy du, the derivative of the outside, right here, multiply with the du dx. the derivative of the inside. So these, we have all of those here. So now I am going to quickly, and so starting with this problem, I am going to write just one answer because two different ways of presenting it is all going to run into the same answer. So now I'm looking at the final dy dx has to be, so the dy du here, at this point, strictly we can't forget to substitute back the meaning of the u right here. And so now I'm looking at 40 times u to the negative 5 power, but now I'm purposely writing the u as an empty pair of parentheses ready to substitute back that original meaning of u right here. So 5x squared plus 1 stays inside parentheses. Okay, and now multiply with, okay, so now du dx is the 10x right here. So 10x multiply. So now I have that our final derivative completed. Okay, so that's one style of how we present our works right there, our steps right there. So in the other styles, like I said, we're still using the same exact solution because we stick with the chain rule. It's just that we writing our steps in a different style of using notation. So again, brief reminder. If we wrote our inside expression as a function g of x, okay, and then our outside function is some function f of x right here. So it was a little challenge at first to see the connection between these as inside and outside, but then once we had it here, once we can tear it down to this, then in this step right now, derivative says dy dx. The chain rule says we need f prime, but f prime of g. Okay, so f prime evaluated at the g of x function and times g prime of x. Okay, and so in that way, f prime is going to be negative 10 as a coefficient of the original function, multiplied with the power negative 4 coming down from the original power, and then the input for x here, I'm going to purposely leave g inside of that. Negative 5 is here. So now I'm going to leave the g 5x squared plus 1. So this is f prime at g. But now I need to multiply with g prime. So g of x is 5x squared plus 1. So g prime here has to be certainly 10x. Simple enough. And so multiply with 10x. So concluding our final answer. That's how we get all the way down to that. Okay. And here we are at another problem. How about part E of our current example? Okay, so this time let's look at how about y equals, let me pick out of my own creativity a number. How about 15, okay, over cube roots of, inside of that cube root, how about 2x to the 5th plus 4. Okay, that's fair enough. 2x to the 5th plus 4. All right, so there we go. We have a function. And once again, let's apply the chain rule to find the derivative of something like this. And now before we start, I observed that we have a cube root being in the denominator, and further inside of the cube root we have, and I said inside of the cube root we had 2x to the 5th plus 4. Okay, so allow me again to share with anyone viewing this video my own experience of how I would choose the inside function. So and pretty much up to this point, doing the fifth part, the part E of our example 1, including all the problems I've done prior to example 1, then pretty much the inside function is mostly a choice like that. There's not really any logical arguments about that. It's just a choice, a decision we choose. And then at some point I will discuss how we can choose an inside function wisely so that makes things work more efficiently, that's all. But now I am going to choose this part right here. Okay, there could be the people out there choosing the entire denominator here to be a u, that's fine too, but I decide to choose something like this, just the part inside of my cube root. Okay, and so once again, another problem where the solution is being presented in two different styles of notation. So how about here, I'm calling that u to equal 2x to the fifth plus 4. Okay, so I didn't leave myself enough space for writing the inside. 2x to the fifth plus 4, and here I can label this here as my inside function. And so that means once we have decided to choose to substitute 2 times x to the fifth plus 4 to be the u variable, then our entire expression here now becomes 5 over cube root of, see, now it's just cube root of u. See how the expression has become significantly simpler. Okay, and this is y equals, and I regard to this final expression, which is now only in terms of the u variable, the new variable that we decided to substitute. And so I call this the outside function. And so with this outside function, notice that the nature of any roots, cube root, square root, fourth root, and 99th root, 100th root right here, but it's a fraction, it's a power. This means u to the power 1/3 here in the denominator. And so altogether I can rewrite this as, this function has a coefficient 5, okay, times u to the negative 1/3, because as I said, this was u to the 1/3 in the denominator, and then being in the denominator, now I can purposely clear that out from the denominator and making it a negative power. So 5u times negative 1/3 power. All right. So same way here. Once we decided to choose 2x to the fifth plus 4 as being our inside function, then we can also have another style of writing your inside function as a g of x function. So g of x here is the 2x to the fifth plus 4, and this is the inside function. Okay, and so for the outside function, once we have chosen the inside, then the outside now can be seen as. So once again, let me do this, but once I hide away that, because all that here is now g of x, so if I hide away all that, then this entire function looks as following: 15 over cube root of something, 15 over cube root of something. So that something there is, we can understand that as a variable x. So 15 excuse me, over cube root of x, 15 over cube root of something, some value. Or we can write that as 15 times x to the negative 1/3 power. Okay, so it looks just, and I have to correct myself a little bit, but back in the earlier style, I don't know why I skipped that one, but it needs to be 1 right here. Okay, but anyway, so now we're on the same page here. So 15 times x to the negative 1/3 right here. All right, so let's now again move to the other board. I'm going to have to spend some time erasing it, but we're going to use this board here to further present our steps. Okay, so this point, recall that u equals 2x to the fifth plus 4. So that means, and of course, with our outside function, again, let me remind anyone viewing the video. So our outside function is 15 times u to the negative 1/3 power. So that means now we can find a dy du first, because the derivative, the overall derivative requires the derivative of the outside, which is understood as the dy du. So dy du here, after what we've seen earlier, then 15 multiplied with the power negative 1/3, okay, and multiply with u, but now to the negative 4/3 power. Okay, so just be careful with the calculation a little bit. This was supposedly, see, let me make it a red highlight right here. That power here was supposedly negative 1/3 originally, but minus 1. So do the math on your own and find out. This needs all together as fraction calculation. The reason I kind of emphasize that, because in my teaching experience, a lot of students, even with calculus level, there is still struggled unnecessarily with fractions. So get yourself comfortable with fractions for me, please. So negative 1/3 minus 1 is negative 4/3. Okay. Now, and all together, and like as I said earlier in quite a few problems already, if you don't want to substitute back the u expression right here into that, that's completely okay. We can leave that for all the way to the end. But 15 does cancel with negative 1/3, leaving me a negative 5u to the negative 4/3. Okay, so that's my derivative of the outer function, of the outside function. All right, so now it's time to move on to the inside function. So u equals 2x to the 5th. So now I can find a du dx. That's the derivative of the inside in this notation. So we're looking at 10x to the 4th, and that's it. Simple, all the simple basic rules apply here, including the simple power rules applied here, and that constant 4 becomes a 0. Okay, so there you go. We have the derivative of the inside function. So now our final derivative, dy dx, according to the chain rule, the chain rule says dy dx needs to take the derivative dy du, which is verbally the derivative of the outside function, multiplied with the derivative of the inside function, where I just now call that the du dx. Okay, and so in that way, now I'm ready for the final derivative, and let's write that final derivative here in this common space. So dy dx in the end is the derivative of the outer function of the outside is minus 5 times u to the negative 4/3 power. So minus 5 times u, but this time I'm getting ready to substitute back whatever the substitution for u was. So I'm going to, instead of writing u, I'm going to write a big, huge empty space right there, fenced by the parentheses to the negative 4/3. So anyone viewing the video should see a general picture of this is the derivative of the outside. And now we're going to put the inside function in there. Okay, so 2x to the 5th plus 4. Okay, and now chain rule says we multiply the derivative of the outside with the derivative of the inside function. So the inside function is right here, 10x to the 4th. Okay, and then that completes our final derivative. And you can also multiply these two coefficients as well, but that's not too important to either carry it out or not. So that's the answer, and how I got to that answer is based on this style of presenting my steps right here. So for the other style of presenting the steps, then so now dy dx allow me to start picking up pace here, but f prime of g of x multiplied with g prime. Okay, and so we have seen these two different styles about 5 times already. And so again, recall for yourself that this is the outside function, 15x to the negative 1/3. Okay, and this is the inside function, g of x being 2x to the 5th plus 4. And so now what I'm doing, but this instruction is clearly saying we need to take the derivative, so it's kind of like all in one step right here. For this, dangerous, a little bit dangerous, but trust me, one day when you're comfortable, I actually like this form a little bit more than the other way, because, all right, so 15 times negative 1/3, okay, and then supposedly something raised to the variables raised to the negative 4/3, okay, and then that's something here. This is where I'm putting in my 2x to the 5th plus 4. See, this now here is my f prime add g of x, and then I need to now multiply with okay, so my g prime is simply 10x to the 4th power, okay. So now after seeing all the little elements together, then the last thing is to cancel out the 15 with that 1/3, and we can now come down to that final answer which agrees with that, okay.